Section 11.2, Part 1, Inference about two means. Lesson objective: test hypothesis regarding the difference of two independent means. Lesson objective: testing hypothesis regarding the difference of two means. In this video, we will learn how to compare two means to see if there is a statistically significant difference between the two. The following three are our assumptions. The samples are obtained using simple random sampling. The samples are independent. The population in which the samples are drawn are normally distributed, or the sample size is large, which our rule of thumb is greater than or equal to 30 for both sample sizes. We have our 6 steps just as before. A two-tail: we will assume that there is no difference between the two means. The alternative is the means do not equal. For a left tail, for the null, we assume that there is no difference. mu1 equals mu2. And for the alternative, we have mu1 is less than mu2. And for a right tail test, the null, the means are equal, mu1 equals mu2. And the alternative is mu1 is greater than mu2. So in this section is very important how we label mu1 and mu2. Step 2 is our level of significance, the probability of making a type 1 error. Step 3, this is our test statistic, and this test statistic follows a student t-distribution. Step number 4, using the p-value, we use table 6 to determine the p-value, or better yet, we will let Minitab or StatCrunch compute the value of p. Step number 5, as before, if the p-value is less than or equal to alpha, we reject the null and conclude the alternative. If the p-value is greater than alpha, we fail to reject the null. Step number 6, we state the conclusion in English. Let's look at an example. A researcher wanted to know whether state quarters had a mean that is more than traditional quarters. He randomly selects 18 state quarters and 16 traditional quarters, weighing each of them and obtaining the following data. So here's our raw data. We will eventually put this data into Minitab or StatCrunch so we can compute a test statistic and a p-value. Test the claim that state quarters have a mean weight that is more than traditional quarters at the alpha equal 0.05 level of significance. So our first step, since our sample sizes are less than 30, we must use the probability plot in Minitab, or we could use the QQ plot in StatCrunch to see if these samples are coming from a population that is normal. So here's for state quarters, looks good. Here's the probability plot for traditional quarters, looks good. If we want to double check, we can do a box plot and we see there's no outliers for either one. So for our assumption, the normal probability plot of state quarters indicate that the population could be normal. A probability plot of traditional quarters indicates that it could be normal or is likely to be normal. So since our assumptions are satisfied, we can do our test of significance, our hypothesis test. So step number 1, we need to state the null and the alternative. So we want to determine whether state quarters weigh more than traditional. So this is going to be a right-tailed test. We have mu for our state, and this is how we indicate it. We do a subscript equals the mean of traditional. So that's our assumption. Now we can write this another way. The mean of state equals the mean of traditional is the same thing as saying if I take the mean of the state minus the mean of traditional, I will get a 0. So these two are equivalent statements. The alternative is the mean state is greater than the, and another way we can say that is we say we take the mean for state, subtract the mean for traditional. That's something going to be larger than 0. So that's step 1. Step 2, our alpha level is 0.05. Step 3, the test statistic is a t. And if we plug in these numbers, we see that t is 2.53. Step number 4, we compute the p-value. And if we did this by hand, we'd have to use table 6, and we would see that the probability is approximately 0.01 according to the table. Now we're going to use Minitab and StatCrunch to actually compute this, which is better than using table 6. In Minitab, we put the data in. State goes in one column, traditional goes in the other column, and it's important that whatever your mu sub 1 is, you put that in your first column, and this is where mu sub 2 goes. So we go to Stat, Basic Statistics, and we want to go to a 2 sample t. We have raw data, so we click sample in different columns. First one we put state, second we put traditional. This is mu 1, this is mu 2. Down here we have the choice of assuming equal variances. We don't know that. Sometimes that's called a pull estimate. We don't want to click this unless we know there's equal variances, so we'll leave this checked off. Click Options. We are testing that the difference between the two is 0, and we change the alternative from a not equal to a greater than. Hit OK, and in the session window we see the test statistic is a t-value of 2.54 and the p-value is 0.009. In StatCrunch, we put in the data. We go Stat, T statistic, 2 sample, and we have raw data, so we will choose what data. We select sample 1, which is state, sample 2, which is traditional. Now default, StatCrunch has pull variances selected. We want to unselect this and hit next. Again, the mean difference is 0, and we want to change the not equal to a greater than, a right-tailed test. We hit calculate, and we see here is our test statistic, t equals 2.54, and here's our p-value, 0.0086. So for step number 5, we know the alpha level, we know the p-value, and because the p-value is less than alpha, we reject the null and we conclude the alternative. Step number 6, at the alpha equals 0.05 level of significance, there is sufficient evidence to conclude that state quarters weigh more than traditional. There is a statistically significant difference between the two means. Thanks for watching.